strange. Okay, there shouldn't be anything new today. It's more of a refresher of everything that we have covered already, but obviously probably at a higher difficulty now. But let me make sure we have covered everything. Yes, we have. So I'll go backwards. I'll start off with growth and decay, maybe even Newton's laws of cooling instead of just the growth and decay, which is more decay based, and then we'll do all the rates of change, the algebraic versions. Okay, so let's go from there. Let's go all the way to Newton's. And let's do, I'm pretty sure I remember doing that one with you guys. We did the turkey. Maybe I left the last one then. All right, let's do this last one as a recap. And if we feel comfortable, then I'll move on back to the other rates of change. If we don't, then we'll do some more growth and decay until we feel comfortable with this. This is from the 2013 Sydney Grammar. Sydney Grammar usually means, look, to me, everyone asks me which trial papers are the hardest. Most people think James Roos. In my opinion, I think Sydney Grammar is actually harder than James Roos, because the grammar school, the way the program that they follow is usually Cambridge syllabus, not New South Wales syllabus. So it's a little bit harder than the standard James Roos work. But anyways, that's my opinion. Sydney Grammar. The city of Mongaville has a large population, M. A rumour begins, and T hours later, the number of people who have heard the rumour is P. It is found that the rate at which the rumour spreads is proportional to the number of people who have not heard the rumour. Thus, dP on dt is equal to K, M take away P. Population, take away the number of people who have heard the rumour. Show that P equals M plus BE negative KT is a solution of this equation. How do we do I? How do we start with I? Any ideas? Come on. I know you guys know it. Someone just say it. How do we do I? Show that it's a solution of this equation. What are we meant to do? Come on, you guys. I'm not going to start it until someone says what I'll do. Unless we genuinely have no idea. Then I need to hear that as well. How do I show that this is a solution of this equation? No, I'm just going to sit here. All right, let's do it. We'll just sit here. All right. Andy, any ideas of how you would start this off?
Not really.
Show that P is a solution of this equation.
Which
this says P. It says dP on dt. So what are you going to do?
Solve for P.
Funny thing is, when we say solution of the equation, we actually don't mean solve here. We actually mean to
make P the subject.
Yeah, well, hold on. We actually mean if we integrated this, the integral of this gives us this. That is actually called the solution. But instead of integrating, because we haven't learned integration just yet, here, of integrating, what we're going to do is differentiate this, and what should happen? It should get you this term here. So for it to be a solution, the derivative of this must get you this. That's a solution. So dp on dt. What's the derivative of m if you're differentiating with respect to t, Andy? Derivative of m as you're differentiating with respect to t. What is it? Is it something, or is it just 0? Or no idea still?
I kind of forgot.
Forgot? So if it's got no x's, you would have, all your constants would have just abolished. They would have gone to 0.
Okay.
So if I've got y equals 2 plus x and I'm trying to find dy and dx, that doesn't have an x. So it's just 0 plus 1.
Okay.
Same logic here. No t, so that just becomes 0. And this, the derivative of an exponential is an exponential, so it's got to be that at least. And then to differentiate an exponential, you've got to differentiate the top power. So the derivative of negative kt is negative k, and then you bring that down. So negative bk, e negative kt. Do you understand what I've just done there?
Yeah.
Exponential is exponential. Differentiate negative kt, negative k, and then negative b, because the b is still there. bk, e negative kt. Is that the first term here? Obviously not. Right? It's got a k, that's great. But you've got negative b, e, negative kt. It's saying somehow that becomes m take away p. Well, I know be negative kt is equal to p minus m. What does that mean about negative b, e negative kt? What is that equal to?
Negative p plus m.
Yep, negative p plus m. So in other words, m take away p, which is exactly what you wanted. Therefore, p equals m plus be, and that every single question will work exactly the same. So it can't change because that's a formula. Is a solution of this equation. Of the equation. Okay, all good. Let's try double I. That was a bit of a struggle for I. Let's see if we're better once it's applied. Assuming that no one has heard the rumor initially, what is the value of B? All right, can someone help me out? Assuming that no one has heard that. So now you just start off with your equation. So you pretty much ignore this for the time being. So we've got P equals M plus BE negative KT. Assuming that no one has heard the rumor initially, what is the value of B?
T equals 0.
T equals 0. And what would P equal to? 0 as well. Because it's saying no one has heard the rumor initially. And P was the amount of people who have heard the rumor.
Yes.
M is the population of Longueville.
Okay.
So P is 0. And of course, P is 0. M plus B, e to the 0 is 1. So therefore,
1.
B must equal to minus
negative
0. Andy, does that make sense?
Yeah.
So then now you don't have B anymore. What you've got it looking like this. P equals M minus M E negative KT. You want to reduce the amount of letters you've got as much as you can. So there you go. That's our new expression. Okay, then I'm sure they're going to give you another piece of information. Triple I. After 5 hours, half the population of Mongerville has heard the rumor. What is the value of K? After 5 hours, half of the population has heard the rumor. So when T equals 5, P equals what?
Is it M on 2?
M on 2, half of M. Because Mongerville, the population of Mongerville was M. Half the population has heard it. Half of the people have heard it. Half M. So you go ahead and solve. So P is M on 2 equals M take away ME negative KT, which is 5. Subtract M. M on 2 take away M. Well, 1 half M take away 1 M is negative half M. Then I'll divide by the M, so M's cancel out. My next line is negative 1 over 2. At this stage, I'll get rid of the negative. I'll get rid of the negative. So I'm left with half equals E negative 5K. Now what do I do to both sides? What would you do to both sides?
You log it.
Log both sides. So then you're left with log 0.5. Log and E cancels. You bring your negative 5K down. And if you've done it right, we log negative 5. Let's just read what the question asked. What is the value? It just said, what is the value of K? It didn't say to write it in any form. So that's it. Log 0.5 over negative 5. Any questions? Okay, let's read that again. So P is this, T is 5, P is M on 2. So I sub that in, I subtracted. Then I divided the M out. Then I divide the negative out. Then I log both sides. Then I divided negative 5. What do we think? Aya, all good with that? Every line?
Yeah, that's all good.
Really? That's amazing. Yeah, that's good. That's really good. All right. All right. And how long does it take for 95% of the population to have heard the rumor? Give your answer correct to the nearest minute. How long? So obviously you're trying to find time. You're trying to find time. Does it take for 95% of the population? I think you guys know what I'm going to say. What is P equal to? Wait, is P how many people did hear or haven't heard it? Who have heard the rumor? Yep. So what would P equal to?
Would it be 0.95 times M?
P is 0.95 M's. And you just do it all again, don't you, Ben? Now, I like I told you guys, and you had this question actually for me this week. You said, my teacher said to just use that answer that I got rounded.
Yeah, you didn't respond to that.
What do you mean? I did.
I didn't get it.
What do you mean? I said, what do you mean? How? I feel sorry and I responded.
I asked you a second part to it. I said, because he said you can use the decimal, but he said use the fraction. But he said if it's in part A, if it says, what did he say? If it says
rounded.
to use part A, then follow it up in part B. But I didn't know if that was right, because then we got two completely different answers.
hold on. Yeah, hold on. The question says, so like this one here, see, like this one just said, what is the value of k? Cool. We found that you could have written it as, you could have written like this, a
Yeah.
fifth log 2. I
Yeah.
didn't. I wrote it as log of half over -5. That it's the same answer. Or
Yeah.
I could have, put that in my calculator. I could have got 0.1386, and I could have written that's 4 decimal places. All of them are full marks. Now, if Triple I said write k to 4 decimal places, full marks there. You're not going to get full marks here, obviously, because they're
Yeah.
rounded. Right? Now, IV, if IV was this question, whatever this question is, IV, right? Exactly. Let's read it again. How long does it take for 95? If IV, you use the answer for Triple I, you will not get 21 hours and 37 minutes. So, but let's see. Maybe you will, but you usually won't.
So we
If you're
just
saying-
every time we use the fraction then?
Wait, let's wait. Help. You're right, but just making it clear, right? So this T would be different. Now you're saying, would I just use the fraction? It's not like that. It's more about using the exact value.
Yeah.
That's what you're trying to say. But yeah, this fraction, but it's more the exact value. So the best way is shift store A. That's it. It's stored. It's locked in, and then you can just use A. You don't have to even use a fraction. So me, the way I would plug it into my calculator is it's going to be just a capital A. So right now in my calculator, I've got this answer. I'm just going to press shift store A. It's locked in. I don't put all this in to my calculator. There's no way you're going to ever see me write this in the exponential bit.
Yeah, but he put the rounded answer in and then it got a different answer to us. That's wrong. So is that wrong?
Yeah, 100%.
Yeah.
Don't do that. Don't
Okay.
worry what you just say. Don't do it. 0.95. You guys should just know that from even before. We write the rounded answer. We don't use a rounded answer. Be careful. 0.95 m equals m minus me. All right, here we go. Take away m. So 0.95 m take away 1 is going to give you 0.95. Take away 1 gives you negative 0.05. If you plug that into your calculator, negative kt. And like I said, I'm just going to leave the k as it is because I know k is just this. Divide m, divide negative. I think we all are pretty comfortable that we get to this line. And then we log both sides. Negative kt, and then obviously t equals to log on negative k. I'll plug that into my calculator now. Log 0.05 on negative alpha a 21.609 20 t equals 21.37 minutes. 21 weeks. What are we trying to do here? Was it time? How long? T was in hours. It looks like T is in hours. See? 21 hours, 37 minutes. And if I did do what you just said, your teacher said to do, which is 0.1386, log 0.05 divided by negative 0.1386, you would have ended up, actually you would have ended up with the same in this case. See? So sometimes it doesn't matter, but you don't know when that time would be. So to be safe, we're going to sub in our whole k value. All good, Aya? I thought I replied. So weird. I don't remember seeing it in replying.
But the first part, you replied to my first question, but I don't remember what it was.
Okay.
Thank you.
All good. So you're actually doing this topic right now at school?
Yeah, we just started, but at first I didn't know it was the same topic because the way he was teaching it was so different.
Yeah.
So
All good.
I was so confused, but I kind of still listen.
Nice. All right. You guys, what do we think? Others? All good? Rosemary, are you comfortable with all this as well? Everything's making sense?
Yeah.
Stefan, what about you?
But yeah, all good.
Good. All right, let's move on. So, yeah, just be like, again, look, show that V is a possible solution to this equation. I'll just do that one because I think we're pretty comfortable with the rest. All you do to that is you differentiate. The derivative of this is bring the negative k down, which is positive 500 k, and then e negative kt. The exponential doesn't change. You can obviously tell that's not that. It says negative k, so my clue to you would be also factorizing negative k out. So you're left with negative 500. Again, can you see that is not v take away 500? But the trick is you just make it v take away 500. So you're right, all right. V take away 500 from this is negative 500 e negative kt. And then, therefore, it's a solution. Andy, make sense now?
Yeah, it does come
Yeah.
back. Yeah.
Cool, simple. But yeah, that will be a question, 100%. See, there it is. Show that this satisfies both this equation and the initial condition. Just always. Don't know. Yeah. Show that satisfies the Cooling equation. So when it says satisfies or whatever solves solution, that's all it means. Don't overthink it. All right. All right, all right, all right. I think we're up to, yeah, back to section 1. All right, let's do it. So those were the hardest ones you could do. Let's do, or hardest for your exponential growth and decay. Now we're going to try this one here, which I think we did. We did do this one. I remember that. We didn't do this one. I think we're pretty much up to this style question, and that's when I went down to some easier ones first. Okay, let's do it. So rates of change. Suppose that water is flowing into a large, rings a bell. Did we do this one? Rings a bell, but I think we should do it anyways. Suppose that water is flowing into a large spherical balloon at a constant rate of 50 centimeters cubed per second. Anyone remember what we do there? Or what that means? I think, Andy, you know it. What does that mean? 50 centimeters cubed per second.
dv.
Good man. Over?
dt.
Yeah, usually, just so you know, for this topic, most of your rate questions, if you see rate, it means on dt. Just keep that in mind. But I mean, yeah, that's time, so seconds. dv on dt, sweet. At what rate is the radius increasing when the radius is, okay, what are you trying to find, Andy? D.
R.
The R on D.
T.
Which equals to dr on dt. What should these two be?
dv.
Done. I need you guys to get to that level ASAP. So the first thing is this, second thing is this. And then, of course, these two cancel out. You need to get to that level. dv on dt you already have. So what you need is this one here. dr and dv, which means I need to find a relationship between r and v for a sphere. Does anyone know any relationship between r and v for a sphere?
4 on 3 pi r cubed.
Is what?
That's the formula for the volume.
V, that's it. V equals 4 on 3 pi r cubed. So of course from there you work out dv on dr. Bring the 3 down and look what you just proved. Bring the 3 down, 4 pi r squared. Does that look familiar? 4 pi r squared, does anyone remember what that is?
Surface area.
It's actually surface area of a sphere. So you can actually know now where it comes from. Calculus created this. But anyways, second dimension, third dimension. But anyways, you don't need to worry about that just yet. Everything will come into play in Year 12. We're here, 4 pi r squared, that's great. You know the radius is 7, so I might as well sub it in. 4 times pi times 7 squared. I got 615.75, so I'm just going to round it up to the nearest whole number. Nearest whole number. All good? You guys understand what I've done there? Subbed in 7. I should put that in. There we go. And then I want a dr on dv. So to find dr on dv, it's just 1 over that. And of course, you're done. dr on dt is equal to 1 on 616 times dv on dt, which was 50. Any questions about that? Aya, does that make sense as well? No? Andy, all good?
Yeah.
Mhm.
Good, good, that's great. I will show you guys something because you'll need it. You don't always just sub in 7 and then plug it into your calculator. Sometimes you need to keep it in exact form. So if it was an exact form, this would obviously be 7 squared, 49, 49 times 4, 196. So this would be 196 pi, which means this guy would be 1 on 196 pi, which means your answer becomes 50 on 196 and then pi on the bottom. So this or 25 on 98. So you need to know it in exact form. So both of them are the same, but yeah, just be aware of that. Okay, good.
Yeah.
Yes.
Where'd the 50 come from?
Say it again. Where did?
50? Where's that 50?
Oh, yeah. Right. 50 was dv on dt. And
Oh,
are
yeah.
you able to recognize that that is dv on dt?
Yeah, because of the cubed, yeah.
Yeah, pretty much. Yeah. Centimeters cubed. And the fact that it says rate.
Yeah.
Good. At what rate is the radius increasing when the volume is this? At what rate is the radius increasing? So again, what is dr on dt? But this time it's saying the same formula, nothing's changing. This time it's saying that you don't know the radius. I gave you the volume. The volume is 4,500 pi. Well, you guys know your dv on dr, dv on dr is equal to 4 pi r squared. So the only thing you can use here is radius. So what you're going to use is this formula. Is v, if v equals to 4,500 pi, you've got to sub it into your original to find radius given volume, because you need radius. You can't actually sub in the volume into here. And that's all, really. Times it by 3. Any questions, you guys, while I complete this off? So cube root r equals 15. And then you just sub 15 in. So dr on dv equals 1 on 900 pi. And then, of course, dr on dt is equal to 1 on 900 pi times 50. Any questions? We're sure we know where I got everything from. So the only difference between B and A was literally the fact that the first one just said radius, which I could simply sub in. The second one said volume, which I couldn't simply sub in. I think I did like one last week or the week before like this. And because you can't simply sub it in, you've got to sub it into the original to solve for R, and then you can actually sub in R, whatever you found, into the dv on dr. So that's what I did here. Found R is 15, subbed it in, and then do the same thing. Okay. What should the flow rate be changed to so that when the radius is 7, it is increasing at 1 centimeters per 1 centimeter per second? Okay. So what's this saying? What should the flow rate be changed to so that when the radius is 7 centimeters, it is increasing at 1 centimeter per second? What is it saying that this is? It is increasing at what is that bit now? Andy, since you're so good at these, what do you think this is? D what?
Is it A?
Oh, nah. A for what? What's A for? A for area?
Yeah.
But then it shouldn't have been squared.
Squared. Yeah.
Right, one more time. It's easier than you think, if that helps. D. Well, this to me is one dimension. Does anyone know? Anyone want to try it? One dimensional? Just a side or something? Anyone know what it would be? What should the flow rate be changed to so that what should the flow rate be changed to? Flow rate is this guy, dV on dt. So you're trying to find dV on dt, it's saying now. So when the radius is 7, it is increasing at 1 centimeter per second. Anyone know what this one is? I'm sure.
Is it S?
Not S.
The L?
S for side, L for length, but you don't have that in spheres. You guys are on the right idea at least. You're saying S is side. I agree. L is length, but it's for a sphere. So you got to think about the letters you use for a sphere. And of course, I just gave the answer.
C. Okay. No.
If you just say C for like circumference.
Yeah.
Yeah, but again, the sphere doesn't have circumference technically.
dr on dt, Sam.
Yeah, dr and dt. The circumference is more for a 2-dimensional shape. We don't do the circumference for that 3-dimensional. But anyways, dr and dt. dr and dt. So that's radius. The radius is increasing at 1 centimeters per second. So you're filling up the balloon at 1 centimeter per second. Sorry, no. Sorry, blah, 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 blah. You want to know what it would be, what you would have to fill up the balloon so that the radius would be increasing by 1 centimeter per second. So now you're given dr on dt. You want to find dv on dt. What should the flow rate be? Flow rate be dv on dt. So I think we know what we've got to do with that one. It's going to do everything backwards, aren't you? C. So dv on dt is equal to dv on, and of course this is going to be dr. You already have dr on dt, that's just 1. Do you know what dv on dr is? Yes, you do. dv on dr is 4 pi r squared. In fact, we already did it at 7. It's 196 pi. So dv on dr is just 196 pi times 1, which is 196 pi in exact form. So that's what it should be. Does that make sense, Andy? I'm sure
Yeah.
it's just the beginning. You guys are just struggling with the beginning, aren't you? Just that first step. All right, let's try it again. Get these first steps out of the way. Have a read of this. I'll be back 2 minutes, please. Sector of a circle. 1993. CSSA. Okay, so if you're going to go below, firstly, if you're going to go below 2010, it's already hard. If you're going to go below 2000s, they'll be even harder because they used to be, I guess, 3-unit, 4-unit combined. It's still 3 units, so it's still extension 1. It's just that it was combined. A bit harder. Anyways, so it's good. Let's do it. A sector of a circle with center O and radius R is bounded by the radii OP and OQ and by the arc PQ. The angle of POQ is theta radians. Okay, so what do we have? We've got a sector, so let's draw that firstly. You guys remember me saying, see, every single question is different, so you just want to expose yourself. That's O, that's P, and that's Q. Angle POQ is theta radians. There it is. And these are the radiuses, OP and OQ, or radii. Given that R and theta vary in such a way, so these are variables, not constants, vary in such a way that the area of the sector POQ has a constant value of 100 centimeters squared. Right. So the area of this is always 100 centimeters squared. Right? So the radius can change and the theta can change as long as the area of the shape is always going to be 100 centimeters squared. Does that make sense, everyone? Show that theta equals 200 on r squared. All right, how do I do the first one? I'm sure there's someone that's already thinking about it and kind of worked it out. How do we do the first one? Okay, well, what's the area of a sector? Maybe we should start with that. What's the area of a sector? Come on, come on. What's the area of a sector?
To do with 3/6 over.
Yeah, tell me. So what's the area of a sector? Just from the beginning. So firstly, it's going to be a circle. So which is what? What's the area of a circle?
Pi r squared.
Pi r squared times. And then
Theta over 360.
It is 360. The only thing is because you're dealing with radians, the idea is you've got to use this as 2 pi.
Oh, okay.
Otherwise, everything will just look very confusing.
Yeah.
All right. So in this case, your pi and pi cancel out, and you're left with r squared theta on 2. All good. And then, of course, you know that, what is this saying? You already know that the area is 100, times it by 2, 200. Oh, come on. Can it get any easier? 200 on r squared. All good?
Wait, where did the 2 go? Oh, times, never mind. Yeah. Oh, yeah, that makes sense.
Yeah. Given also that the radius is increasing at a constant rate of this, so what is this equal to? Andy, we're going to pick on you today. Keep going. Tell me what do you think this is? D what?
Wait, that's a
Given.
power of
Also,
-1.
Yeah, power of -1 just means per second. So like meters per second, you could also write it as ms -1.
Yeah.
They probably missed the s.
Is this okay?
Given also the radius is increasing at a constant rate of what is this equal to? D. It's right there. You're making it harder on yourself.
dr.
dr. It's right there. It's either going to be, look, it's good for you to know this. It's either going to be r or theta because that's the only two variables you've got. The area is going to be a constant, so it can't be the area. So it's either r or theta. And it's saying that the radius is increasing at this. So that's dr on dt. Find the rate which this is decreasing. So what does that mean? Find the rate at which this is. So what are you trying to find? D what? Find the rate which angle POQ is decreasing. POQ. Andy?
An angle?
Yeah, it's an angle, but isn't that angle theta?
So that works.
Of course.
Okay.
Yeah, absolutely. DT, anything. I could even say, look, I could write D Andy on DT. It just means
yeah.
it just means Andy is changing with respect to time. That's the idea. So theta is changing. The value of this angle is changing as time is changing. That's what the rate means when it says find the rate which this is decreasing. Or in this case, the radius is increasing. So it's getting larger by 0.5 centimeters with respect to time. And so that needs to happen, right? The radius has to get larger and the angle needs to get smaller because they both can't get larger. Otherwise, the area won't always be the same. Or other way around. If the angle was getting larger, then the radius would need to get smaller if you're going to keep the area the same. So logically, it makes sense. But yeah, so anyways, you're trying to find d theta on dt. D theta on dt is d theta on what? And what on dt? What letter? Go back. What letter did you use here?
dr.
dr, right? So you're going to use dr. You already have dr on dt. That was given, 0.5. D theta on dr, there it is. You've already got theta equals 200 on r squared. You know, we can't have x's in the denominator when you're trying to differentiate. So no r's in the denominator when you're trying to differentiate. D theta on dr is negative 400, r negative 3. And then it's saying that r is 10. So you'll just sub in 10 into here. So negative 400 times 10 to the power of negative 3 is negative 0.4, and we're pretty much done. That is d theta on dr, so there's nothing else for me to do, times 0.5. Which gives us negative 0.2. And you can see it's decreasing because negative as well. The fact that it's negative means it's decreasing the rate. You're losing 0.2 radians per time. So this is decreasing by 0.2 radians as radius is increasing by 0.5 centimeters. That's a different application, but I hope I'm showing it to you guys that we're kind of doing the same thing. We need that line, we need this. All right, let's go again. Go again, let's go again. Let's see, we'll do the first one. Let's do this one first, actually. All right, Ben, you can try this. Have a read of it first.
Okie dokie.
And then we'll do it, I guess. And write down everything like that you know and you want to use. You probably see a few things. But yeah, have a read first. right, Ben, talk to me. A solid wooden cylinder of height 10 centimeters and radius 6 centimeters with its base of horizontal table. The light source P is being lowered vertically downwards from a point above the sensor or the top of the cell at a constant rate of 0.1 centimeters. So what does this equal to?
I got DH on DT. Would that be right?
I think you're right. Let's read that again. The light source P is being lowered vertically downwards from a point above the center at a rate of 0.1 centimeters per second. It's getting lower, so the height is changing. Height changing at 0.1 meters per or centimeters per second. Good job. That's it. You found your DH on DT.
Mm-hmm.
When the light source is H above the top of the cylinder, the shadow cast on the table extends R centimeters from the side of the cylinder as shown, as you can understand. All good?
Yep.
Show that R equals 60 on H. I think I know how I would do that, but what would you do? I had an idea.
How would I
actually.
do that?
Okay, that's
I mean,
right. Yes.
oh wait, no, you go first.
No, I can't. I'm not.
I
I'm just
mean,
trying to work out because the first thing I saw was
it was
Pythag,
already
but
okay.
it won't work. But yeah, go ahead.
I thought the radius would be 6 because on the cylinder it
No,
says 6. Would that
the radius
Okay,
of this
okay.
cylinder is 6. Are you trying to say R is
be
6?
6? Yeah, I got confused there, yeah, and then I realized that's not the
This-
same.
Yeah, that's not the same. This is just R, as in we can change it if you want to make it to D.
Uh,
There you go. The R's don't matter.
Yeah.
That's the radius. It's the distance here that it's casting the shape. That's
Mhm.
6. That's H. Good. Is good. Thinking is good. Because what if this was in your exam and I never, we never
Yeah.
copy and pasted this, and what would you guys have done? You can't really. You want to expose as much as you can, which is what I've always said with these rates of change questions. But the reality is, you're not always going to complete absolutely every single question. So
Yeah.
just got to think. Now you're here. You know you need a relationship. Anyone see anything? Can help us out? Let me make sure I've got it as well. So I would have done this and that, that and that, and then that. Pretty sure. Yeah, should work. No, nobody has any idea what they would have done in an exam. So you're pretty much saying you would have. And if you did, it's okay. 0. Ben, you got 0. I need to show you guys this because I'm worried that if you guys get taught always to just do I, you're never going to learn how to ignore it. So Ben, sorry,
Yeah.
you couldn't do it.
All good.
You do now.
Yeah.
You read. On the rate at which D is changing when H is 5. So obviously you want to find D. That's a horrible choice of a letter, which I didn't forecast. I'm going back to R's. Sorry.
It's okay. It's okay.
DR on DT, of course, you're trying to find. So DR on DT is going to be DR on what? And what on DT?
It'll be DH, right?
DH, because obviously that's given to you. And you already know what DH is on DT, that's 0.1. So that's sweet. Equals times 0.1. Now you need a relationship between R and H. Do you have something there that has a relationship between R and H?
The volume. The volume is 2 pi RH.
No.
Oh wait, no.
Don't need that. Look what you've just used when it said volume is 2 pi h, let's just say, plus blah, blah, blah. But why? Which it isn't. Volume is not that.
Yeah.
But why are you trying to introduce another letter? You know? Don't do that. That's going to complicate things. Unless you needed to, but no. Is there a relationship between R and H, Ben, that you've got? Of course.
Would it be like the pipe?
No,
Wait.
close. R and H. Relationship.
I don't see it. Oh wait, I see it. I see it. I was looking at the shape for some reason.
I know. Hence why I was trying to
I was
say
just
you
there.
got to teach you guys how to move on. If it's a show question, they gave it to you so in case you couldn't show it, you guys can still get 3 out of 4. If I don't teach it to you guys like that, you guys are going to get a 0 out of 4. And that's bad. You cannot get 0. It's the minimum is 3. 3 out of 4. So, do you have a relationship between R and H? Absolutely. Given to you because you couldn't do it. R equals 60, H negative 1. What's dr on dh now?
It'll just be negative 60 h to the power of negative 2.
And then, of course, h squared is saying h is 5. And then you've got negative 60 on 25. Simplify that. You get negative 2.4 times 0.1. And you're done with that. So, yeah, Greg, be careful. I don't know what.
Yeah.
Hold on. Source P is being lowered vertically downwards from the point above the center with constant rate. So what you're trying to say, make dH on dt negative 0.1? Yeah. That's all right. Good point. So probably something I missed there. It's being vertically, it's being lowered. It is actually negative 0.1. If it was increasing, it's negative. If it's increasing, it would have been positive 0.1. So what should have happened is this should have been negative 0.1. And then that gives me a positive 0.24. Just be aware of that. Good point. Okay, Ben, back to I now. So now that we can get our 3 marks here, or if you're Sam and you fail to see that negative, you get 2 out of 3. But at least we should have got 3 out of 3. I shouldn't have missed that. Vertically. Okay. Still can't see it. H 6 10 R. Does that 10 help?
Well,
Huh?
Is it something to do with Pythagoras?
No. It's actually got something to do with it. It's a topic you would have learned only last year. And then
something to do with the 2 triangles?
Yes.
Like triangle, small triangle?
It is. It's similar triangle. So it's H over 10. That's equal to the same ratio as 6 on R.
Was this like congruency or something?
Yes, similarity.
Yeah, okay.
So that's out of the syllabus now. See, it's assumed knowledge like that. Just basic basic ratios is just assumed knowledge. So you understand that to that must be in the same ratio as that to that.
Yeah.
But anyway, of course you cross multiply HR equals 60, so R equals 60 on H. I can't keep saying it, but I'll say it one more time. The only way you guys are going to do really good at rates of change is not by doing your textbook questions. This one here specifically can only be done by exposure to exam questions. That's it. There's no other way around it. You cannot rely on your textbook for these at all. Every single question is different. The thinking is different. So, there'll be a lot of exams here. But there you go. Ben, you lost 0. It's okay. It's not a problem. You didn't know what to do. Who cares?
It's been there
At
for
least
next time.
going next. Yeah, of course. Now you know it. Yeah, of course. But I'm trying to say it's okay for you guys to get 0. But it's not okay for you guys to skip these next marks. Cannot do that. Not a good habit to get used to.
Mm-hmm.
That looks interesting. So we're going to do it. Let me just see what else is left. Lamp. We'll try that as well, I guess. Oh, no, sorry. I want to do these ones. 2 chains. So these are the ones that well, you'll see, actually. It's better for me not to say anything. You'll just see. They're a multiple choice. Oh, that's annoying for it to be in a multiple choice. Let's do it. So let's have a read of this. The volume of a cube is increasing at a constant rate of 100 centimeters cubed per second. Andy, come on, tell us. What's this one? D.
DV.
Done. On DT. At what rate is the total surface area of the cube increasing? What are you trying to find?
A.
On DT. So therefore you'll need DA on D what?
DV.
Correct. But do you have a relationship usually between area and volume of a cube? Well, okay, hold on. What's the volume of a cube? Just quickly. S cubed or X cubed or whatever letter you like. What letter? Andy.
Yeah, S cubed. Yeah.
S cubed. Boom. And then what's the surface area of a cube?
S squared times 6.
Times 6 sides. S squared. Now, do you have a relationship between area and volume? Not really. Like, do you know what is? Do you have a relationship between area equals to something with volume, or other way around? So what you're going to do is break up this dA on dV again. So, Andy, dA on what? What do you think? You just did it up here.
Wait, what? Oh,
It's going to be ds because do you have a relationship between area and side length?
no.
Yeah, absolutely. Do you have a relation between volume and side length? Yes, absolutely. And that's how this works. What about everybody else? Does that make sense? Aya, Stefan, Rosemary, does that all make sense? Ezra, does that make sense as well? How I split it all up? Do we have any questions for me? Do you understand why I had to split it up in the first place? Okay. dA on ds on dV is 1 over that, because it's the wrong way around, times dV on dt is just 100. But it's saying when s, the side cube length is 10, So you're going to sub in S is 10. For a multiple choice, which is why you'll probably hear me with two kids. I said the last thing you want to do is the multiple choice. Because there might be worth 1 mark, but there definitely isn't 1 mark of working out here. This is usually worth about 3 marks. But, yeah. All right. Let's go again. Okay. Greg, let's do this.
Wait, Sam, can you go up for 2 seconds, please?
Yep.
Any questions? All good? Otherwise, you're just copying. I know you're copying, but anything you want to talk about?
It just froze on a blank thing for like a few minutes.
Oh, fair enough. Does it all make sense, though?
Yeah.
Do you understand why? Do you understand why I had to move from here to here? Do you see how I would be stuck? I don't have a relationship between A and V. Whereas all the other questions we did,
There was a
that's
relationship.
there was a relationship. Yeah.
Yeah, but I
Like,
feel like I couldn't do that on my own. Yeah.
yeah. Yet.
Yeah.
Yeah, that's okay. So we're going to look at this one, and we'll see how you find this. All right, Greg. Let's do example 10.
Yep. So
Spherical bubble is expanding so that its volume increases at a constant rate.
mhm.
Volume increases. I think that was meant to be cubed. That's probably a typo, but that's okay. We can fix it up. So that's
Yep.
volume increase at a constant rate of 70 millimeters cubed per second. What is the rate of increase of its surface area when the radius is 10? Okay. What do you have? What do you know? What do you want to find?
So we want to find dV on dt.
Nope.
The surface. Oh yeah, the dSA on dt.
Yeah, but don't use 3 letters. 2 letters are fine. So
yeah,
DA.
right.
DA on DT.
Mhm.
What do you have?
So you want dA on dV, and then you want dV on dt.
Obviously, yeah, you have dV on dt.
Yeah.
Good. And then again, it's a sphere.
Yeah. So
can
you
a
have
relationship between area and volume. But yeah. go ahead.
4 on 3 pi r cubed for the volume, and then you differentiate.
Yeah, but you're memorizing this, right?
Oh yeah.
Got it. I understand what you're saying.
Yeah.
The area is 4 pi r squared.
Mhm.
You've memorized this, but what you want to try to remember is dA on dV. Yeah, cool, I got it. And then, oh yes, I got to split up this into 2 other things.
Yeah.
Because it's not always going to be as simple. But yeah. dV on dr, you differentiate, which is just 4 pi r squared.
Yeah.
dA on dr is just 8 pi r. Sub in your radius, which is 10. 10 squared is 100, 400 pi. This one's just going to be 80 pi. So therefore, dA on dr is 80 pi times reciprocal of this one.
1 on 4 pi r squared.
Times 70.
Yeah.
Pi and pi cancel and just plug it in, and that's it. I'm guessing it gives us 14.
Yes.
Good. Good. Oh yeah, what about that one? Better?
Kind of the same.
Kind of the same. Where are
Yeah.
you getting stuck? Knowing to do the volume and area formula, or knowing to do the first step, or the splitting up?
Like I get it when you it all makes sense, but I just feel like
Yeah.
by myself, like I don't think I can do it by myself.
Yeah,
Yeah.
just I get it. All right, I get it.
Yeah.
I get it. Okay, these ones probably the most annoying ones because you can probably see the first word and the second word purely algebraic. So there really isn't numbers, which means you've got to be 100% with your algebra. And probably the hardest bit of rates of change. So we're going to do these, and I think we are done. Yes. The last two, hardest two, and the ones that you want to spend a lot of time on, because they're the ones that a lot of students would fail, and that's where you can differentiate yourself compared to your peers. So let's do this. I'll give you a few minutes just to have a read, maybe write a few things down, and then you can see where yours would be different, let's say IR to mine, and then you'll see where you're stuck exactly. Just write a whole bunch of things down, and I'll get started shortly. I'm going to read it as well. So hemispherical bowl of radius R is initially empty. And actually, Azra, you're going to do this one with me. I think it's a really good one for you to be able to master. Okay, Azra, you ready? Azra? I don't think. Oh, okay. Fair enough. Fair enough. Fair enough. Then who do I want to go for? Oh, okay. Yeah, Rosemary. Let's do it. You and I. Let's get this done. Purely algebraic problems. All right. You ready, Rosemary?
Yeah.
This one here. Water is poured into it at a constant rate of k centimeters cubed per minute. This is D what?
D.
So you already have dV on dt. When the depth of water in the bowl is x centimeters, the volume is of the water the volume of water in the bowl is given by this. So that's a relationship between V and X and R. V, X, and R, which is fine.
Yep.
But it looks like yep, R is a constant because R is the radius of the bowl, right? So R is just a constant. That's not changing. It's not the radius of this, the radius of the water. If it was the radius of the water that is getting filled up, well, that's changing because obviously if it was down here, it would be smaller than if it was up here and so on. But R is just the radius of the bowl, which is just a constant. So R equals constant, and you can probably see that in the answer here where they still got R. Okay, the question's asking you to find dx on dt. Okay. So you would write this. You'd be like, all right, easy. dx on dt is dx on something times something on dt. What letter would you pick? D what?
DV.
Correct. It's always this guy. Always. Always the beginning one, whatever that is. DV on DT. Now, you already know what DV on DT is. That's K. So let's write it here. DV on DT equals K. Now, you need a relationship between V and X. Do you have a relationship between V and X? Right there, yeah? So, of course
Yeah.
you do. Now, you need to differentiate this. All right, it's up to you. Just be careful. What do you want me to do with this? V equals pi on 3 x squared, 3r take away x. You can't differentiate it just like this. But you've got two options. So I'm leaving it to you. What do you want me to do? You're just not allowed to leave it like that and differentiate. You've got two options.
Put over a common denominator.
No need. No need to do that. Nope. You can't differentiate because there's two x's that are multiplied. If that,
Expand.
yes, you could expand in this case. So that's option one. So you could have written 3 over 3 is just 1. So you could have written pi x squared r and then minus x cubed pi on 3. Do you agree with that? So let me just make sure.
Yeah.
3 pi minus, yep. So, and then what
Yeah.
is dv on dr now? Okay, so differentiate this with, okay, yeah. What's the derivative of pi? Maybe I should have written r here, but anyways, pi x squared r.
2 pi rx.
Whoa. Hold on. I just realized I read dv on dr. I'm so used to volume with radius. Sorry. dv on dx. You're differentiating with respect to x. And I think you still said it anyways. 2 pi r x. Good girl. R is a constant. Pi is a constant. I just bring the 2 down and keep the x.
Yeah.
Minus. And then same thing here. Bring the 3 down. X squared pi on 3. 3 cancels out. So you're left with 2 pi rx minus pi x squared.
Yep.
Good. Just so you know, the second option here, the one I was talking about, would have been product rule. Because you've got an x
Yeah.
multiplied by another x. You could have done product rule. But because if it was power of 3, you definitely needed to product rule, just so you know. You can't do it any other way. You're not going to go expand this and then bring it in. So just be aware of that. But
Yeah.
probably what you just did was the fastest way. dv on dx is this. So dx on dv is not that. You obviously would flip that. So you're going to get 1 on.
1
Two.
on 2 pi rx minus pi x squared.
And then times by k. Have a look at what you have. Have a look at what they need. And I think it tells you what to do. What are you going to do in your next line?
K on factor out the pi and the x.
Yeah, pretty much, right? So me personally, I'll just write the question out again if I can see it. And I think we can see it. Just rewrite the question.
Yeah.
Done. So that's how these work. Purely algebraic means there's not going to be any numbers. Your algebra is going to be spot on.
Yep.
Pi is going to still be there. R is going to be there. Good. Good. That was really good, Rosemary. Well done. Excellent.
Thanks.
Double I. Hence, again, you couldn't do it. You get 0. That's not a problem. Or get 1. If you wrote, you'll be surprised. If you wrote this, that's 1 out of 2. How funny is that? That's 1 out of 2 just for writing that. But anyways. If you get 0, it's fine. At least try to get 2 marks here. Hence, or otherwise, show that it takes 3.5 times as long to fill the bowl to the point where x is this, as it does to fill the bowl to the point where x is 1/3 of r. Well, okay. Okay. Show that it takes 3.5 times as long to fill the bowl. Okay. So the rate at x equals this.
Would you
x
sub in x?
Yeah, that's pretty much what you're going to do. So when you sub in x, you're going to work out the rate that the height is changing. And so what it's trying to
Yeah.
say, show that it's 3.5 times as long. That's with respect to time. Oh yeah, yep. It works out. It works out. So sub in x. So where are we? Dx on dt at x equals 1/3 r. 1/3 r. Dx on dt equals, here we go, k on pi x. X is r on 3, so r on 3, open bracket, 2r minus r on 3. Looks like a whole big beautiful mess. So what I usually do is go equals k.
Separator.
Divide. Say it again. Is that what you're thinking?
Separator? Yeah.
And then that goes what? Pi r on 3 times.
Would you put
This
it
guy-
all over 3?
Soon. That's what I'm about to do right now. Well, actually not all over because that's multiplied, isn't it? So be
Yeah,
careful.
so pi r to r minus x all on 3.
Uh, 6r minus r on 3. But then when you do 3 and 3 here, it's going to become 9. That's multiplied, right? So it's not all over 3. It's not all over 3 because it's not a plus sign. So be careful there. That becomes 5r on 3. 5r times r is 5r squared pi on 9. And then I think we're just about to wrap it up. So cross multiply it, 9k on 5r squared pi, which looks like a mess
Wait, why'd you write 6r?
because 3 times 2 is 6r, take away r on 3. So I'm doing common denominator only for this bracket.
Okay.
Yeah. It's not a common denominator for the whole thing because that 3 is still meant to be multiplied by the 3 that's down here. Do you get me? So like the bit you're missing
Yeah.
is if it was like this, I'll just show you what you're trying to say. If it was like the 6x on 5 plus y on 5, yes, you would have said, okay, make it a common denominator. The answer is 6x plus y on 5. Easy. If it wasn't like that, and if it looked like this, 6x on 5 multiplied by y plus x on 5, well, technically this has got to expand to these two. So the common denominator isn't really going to be on 5 because by the time you expand this guy with this, it's going to be on 25. So when I make a common denominator for my inside bracket, which is 5y plus x on 5, and then I expand.
Yeah,
Well,
I wrote it wrong, so I understand.
Yeah. Oh,
Yeah,
I don't know about I think it's more that happens. Just so you know, what you've just done there is one of the biggest problems with these style of questions. So a lot of students go, oh yeah, 3 is just 3, but no, careful. That's a bracket. That's a times. 3 times 3 is actually 9. Okay, so that's that. 1 on 3r. You're going to do all of that again for 2 on 3r. Double one. At x equals 2r on 3. Dx on dt, okay, again, equals k divided by, so now we can just kind of copy this, r is, r on 3 is 2r on 3. This would have been 2r minus r on 3.
3?
Right? Sorry, 2r on 3. Sorry, like that. Do you agree?
Yeah.
And then this should have been 6 take away 2, which is 4. 4r on 3, and then that just becomes now 8r on 9 instead of 5. So we've got what? We've still got 9k on. Now we've got 8r squared pi. All right. Hence, we'll show that it takes 3.5 times as long to fill the ball to the point where this. Okay. 3.5 times. Three and a half, 7/2. It doesn't. Where is my logic wrong there? Sure, that takes 3.5 times as long. So time. Try to find the time. Find time.
Does that mean you would find time?
Yeah, I'm just thinking dx on dt, but that is what? That is the change, that is the rate at the x, what's x?
The x is.
That's the rate that the height is changing with respect to time. For you to find time, you've got to integrate, which I don't think is part of the rate of change here. Let me just make sure this, I've got these answers up. Hubert. No. Let me think about it again. Sure, that takes 3.5 times. So the time it takes for this to get to here yeah, you would have to integrate and then sub in x equals 2/3. That's the only way. But I don't think integration is part of it just yet. Let me just make sure. Show that v equals. All right. You guys are going to give me 2 seconds. Actually, I'll just go get the answers. Pretty sure. Which I don't think is part of what we need to do just yet. 2006. Let's make sure it is from this paper firstly. Yep, there it is. Question 5C. Question 5C. Yeah, exactly. Some can determine t by integrating successive found 2 times. The only way you're going to be able to do that is by a smaller number of candidates could not simplify the result. The third option was to substitute a given equation for v, but most of the candidates who chose this method did not explain that this was possible because v equals kt. Yeah, like I said, it had to be done by integrating, which I don't think is just, it's part of what you need to do just yet. Because integration is not really part of the year 11 course just yet. So can't do that one. So not yet. Unfortunately, I should have realized that from the beginning. Doesn't matter. Diagram shows two identical circular cones. Let's make sure this doesn't have an issue. From the rate average V, from the rate average V. Yep, that one should be good for us. Common vertical axis H and semi-vertical angle 45 degrees. All right, it's got an exclamation mark. Exclamation mark means it's going to be silly hard. So let's hope it's not too hard. The diagram shows two identical circular cones with a common vertical axis. Each cone has height h, so that's h, and that height there will also be h, and semi-vertical angle of 45 degrees. The lower cone is completely filled with water. The upper cone is lowered vertically into the water as shown in the diagram. The rate at which it is lowered is given by dl and dt, where L centimeters is the distance the upper cone has descended into the water after t seconds. That makes sense. As the upper cone is lowered, water spills from the lower cone. The volume of water remaining in the lower cone at time t is V. All right, show that V equals to this. 1 mark. Okay, V equals to this. All right. Well, what does V equal to? What's the formula for V? Volume of a cone. One on 3 pi r squared h. Right? 1 on 3 pi r squared h. Now you can clearly tell just by looking at this and looking at your formula that if I put the pi on the top, I put the h on the outside, pi on 3h, you can kind of tell that r squared should have been, h squared minus, let's say, something to do with L squared, something like that. So that when you multiply it by h, that gives you h cubed, and then let's say hl squared. That's my logic anyways. It could be completely wrong. But let's see how we're going to attempt this. So what am I thinking? I'm thinking that's L, that's H. That's H. That's L. You don't know that. You know that. The radius R. You know that's 45 degrees, so if that's H, you can work out R. That's 45 degrees, that's H. I can work out R by doing opposite over adjacent, so tan 45 is equal to opposite R over adjacent H. Tan 45 is 1. So therefore you'll just get R is equal to H. Of your H as well. Does it? That just gives me H cubed minus L cubed. L, I got to bring L in somehow. The volume of water remaining in the lower cone at time t is this, sorry. The volume of water remaining in the lower cone. So what I've got to do is find the volume of this. Right, because I just said R is equal to H. So the volume of the original, so the volume of the bottom one, originally it's pi on 3 H cubed. Do you guys get that? And then the volume that we want, the volume of water, V, the volume of the lower one, volume of remaining, must be volume of the original minus volume of the lower cone here, which is smaller cone. And the volume of the smaller cone is equal to 1 on 3 pi times the height, L, times radius of that. But we just worked out that R and L would be the same thing because R and H are the same. So I might not call that R, I might call that X. And if that's 45 degrees, well then L would equal to X. And then you're just going to get pi L cubed on 3. I think I would need that explained again to you guys. Do I need to explain that again? And then you're just going to factorize your pi on 3 out. And that's that. That was a really hard one, Mark. But there you go. All right. What bit do we understand? What bit do we absolutely not understand from all this? Because that was hard. Really, really hard. What do we get? Should we read it again? As the upper cone is lowered, water spills from the lower cone. The volume of water remaining in the lower cone is V. And it says show V. So you want to find whatever's remaining, which I did as the original cone, take away the smaller cone. And the smaller little for the height, just like this was, and then that's X, but then when you do it again, X and L, you're just going to prove the same thing, except L equals to L is equal to X. And therefore your formula just becomes 1 on 3 pi L cubed. And you just subtract. It's hard. I'm not going to say that's easy. To think like that, a lot of experience. You guys got to get to that level. If you're aiming to get to 99 and 100, right? We're not talking about band 6. Band 6 is not these kind of questions. Band 6 is a lot easier. But if you're going to get to the 9900, you pretty much need to think like this. Find the rate at which V is changing with respect to time when L is 2. So find the rate at which V is changing with respect to time when L is 2. What does that mean? What am I finding for double I? Can someone tell me what I'm trying to find for double I? Greg? What are you trying to find?
dV on dt.
Yep, you're trying to find the rate that the volume is changing with respect to time, so dV on dt. Okay, and let's do that. Do I have some paper here? Yep. dV on dt equals dV on something times something on dt. Now, you would have probably chosen dl, right? Because they gave you dl. Where are we? They gave you dl. So you probably would have chosen DL, and that's actually not an issue. DL, DL. Now, do you have a relationship between volume and L? You do, don't you? Right there. Volume and L. Because L is the one that's varying. That's L changes. Your H here doesn't change. Your height of your cone is not changing. So height is constant. So V equals pi on 3. So let's just expand this so you guys can see it a little bit easier. Minus we want to find dV on dL. No L's, that's just the constant, so it's gone. Minus 3 pi L squared on 3. 3 and 3 cancel. I'm left with negative pi L squared. So dV on dL is equal to negative pi L squared times dL on dt. dL on dt was 10, and he said L is 2. L is 2. So you can see double I again was a lot easier than I. And it is like almost always the case for all the hard questions. What was L again? 2? Yep. Almost always the case. So negative 40 pi, which makes sense. You're losing 40 pi each time. At that time, sorry. So, and then triple I. Find the rate at which volume is changing when the lower cone has lost 1/8 of its water. Give your answer in terms of H. Again, find the rate at which V. So again, you're trying to find dV on dt. Again, it's dV on dL. The only difference in the question is the fact that it's saying the lower cone has lost 1/8 of its water. So the thing is, the volume of water remaining is V. If it's lost 1/8, how much is still remaining?
7/8.
7/8. So, so capital V is 7/8 of the original volume that you just found, which is pi on 3 H cubed minus L cubed. So 7/8 of pi on 3 H cubed minus L cubed. And then expand. H cubed on 24 minus 7 pi L cubed on 24. Differentiate dV on dL. dV on dL. That becomes negative 21 pi L squared on 24. And yep, that's good. Negative 21 pi L squared on 24 times 10. Again, we need to find L. How do I find L? You know what the volume is. It's 7/8 of this. So 7/8 of the, wait, hold on. Find the rate at which V is changing when the lower cone, yeah. So my V is 7/8 V. No, I did that part right. Changing when the log cone has lost its. Where am I? Where did I lost my track? The log cone has lost 1/8 of its body. Give you an answer in terms of h, of course. So therefore, pi on 3 h cubed minus l cubed, that volume, is now equal to 7/8 of that. That's right. So 7/8 of pi on 3 h cubed minus l cubed equals no. Whoa, what am I doing? Hold on. Let's go again. Find the rate at which V is changing when the lower cone has lost 1/8 of its water. Give the answer in terms of h. So the volume is this. So 7/8 of this. No, that's wrong. Where am I going wrong there? I need to find L. 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 Where am I stuck with this? Let me think about it. I need to find L. H is constant. That's not a problem. V. You know the V, the amount remaining, is 7/8 of this. So this equals 7/8 of this must equal to this. Solve for L. Why do I see that not working out very well though? Let me try it again. 7/8 of pi on 3 h cubed minus l cubed must equal to h on 3, sorry, pi on 3, h cubed minus l cubed. So 7/8 of your volume remaining, 7/8 of your volume remaining must equal to your volume remaining. No, that doesn't make sense. That does not make sense. Where am I going wrong? Where am I going wrong? As the applicant is on water source from the volume is changing. Find the rate at which V is changing when the log cone has lost 1/8 of its water. Give the answer in terms of H. Okay, it's original water, the volume of water remaining in the lower cone at time t. Originally, the water was full. That's where I'm going wrong. Okay, perfect. Originally, the water was full. There it is. That's what I needed. All right, so originally the water was full, right? So the water was full, which was at pi on 3 h cubed. It's 7/8 of that now. That's where I was trying to get to. So originally the water was pi on 3 h cubed, and we're at 7/8 of that. So 7/8 of the original amount, pi h cubed, right? Was that pi on 3? So 7/8 of the original amount is equal to the water remaining. Or yeah, 7/8 of the original amount is equal to the water that is remaining. Now you're solving for L cubed, or L. So you can see even me attempting it, I should have crossed out the pi and probably multiplied the 3. But anyways, you can see even me attempting it, I've got to read the questions again and again and again a few times. And that's how they're pretty much made. I would have times it by 3 at this stage. I should have just done it here. So that should just be 21 pi. And then I would have got rid of the pi as well. So 21 over 24 h cubed minus times it by 3. Didn't I say that? minus h cubed equals negative L cubed. And then get rid of the negative, that makes this into a negative, times everything by 20. Nope, don't do that. So then L equals h cubed minus 21 h cubed on 24. 21 on 24 is 7 on 8. So that just becomes cube root of h cubed minus 7h cubed on 8. Ugh. 7h cubed on 8. So therefore L squared, which is what we needed, is going to be this. Negative 21 pi L squared. L squared would be cube roots of 1 on 3. So it would be cube root of h cubed minus 7h cubed on 8 squared on 24, which again simplifies, times by 10, which is 210. And that pretty much is the answer we're looking for. Negative 210. I know that one's not good for you guys, but at least you've got a question that is ridiculously hard, and you can do that on. You can just go rewatch that and see if you can manage to understand this. If you don't want to write the cube root, you could write it as 2 over 3. And that's it. You could have factorized your h cubed out, actually, now that I see that. You factorize your h cubed, and you could have written the h on the outside with just a single h. Oh yeah, this can work out really nicely. Okay, hold on. I'll make it look even better. Sorry, I should have realized it. I'm going to take this out. Negative 21 times 10 is 210. Divided by 24 is 35. So that becomes negative 35 pi on 4. That's this and this and this. So that's gone. Now, here I can factorize. I should have done it from the beginning. Factorize your h cubed out. But it's okay. I'll still do it here. Factorize h cubed. And then it's still squared. And then you're left with 1 minus 7 over 8. Squared. And then what happens is cube root of h cubed squared becomes negative 35 pi on 4. The h cubed and the cube root cancel out, so you're just left with h squared at the outside. And then 1 minus 7 over 8 squared is 1 on 64. And then when you cube root that, gives you a nice, beautiful answer of 1 over 4. No more cube roots, no more surds, nothing like that. And that's the answer. H squared on 16. So, holy crap. Oh. At least you got to see a really ridiculously hard question. Question 7, that's the last one. So like I said, this is not really a band 6, this is more state ranking. So if you want to get to that level, that's pretty much the style of question you've got to be able to answer eventually.